2.3, dividing mixed numbers. So this lesson is actually not all that difficult after going through 2.2 because all it is dividing mixed numbers. And how you do that is you write each number as an improper fraction and then you divide as you would with proper fractions. So I'm going to list out those steps as you go. Example 1 is dividing a mixed number by a fraction. If I had to find 2 1/4 divided by 3/8, I'm going to rewrite this out, so I'm going to down a little bit. And then my first step would be make this into an improper fraction. So as we learned before, you're going to take 4 times 2, which is 8, plus 1, which is 9. So that becomes my numerator. I keep the same denominator at 4. I'm going to leave my division sign, and then I've got by 3/8 because that's not a mixed number. My next step is to think about these steps. Leave it, change it, flip it. So I'm going to leave it, change it, and then flip it. Remember, when I flip it, that's called the reciprocal. And now I can solve. So again, my cross factoring, so I'm going to look from crisscross. And I've got a 3 and I've got a 9. Obviously 3 is a factor of 9, so 3 divided by 3 is 1. 9 divided by 3 is 3. And then 4 is a factor of 8, so 4 divided by 4 is 1. 8 divided by 4 is 2. Now remember, with multiplication, you just go straight across and multiply. 3 times 2 is 6. 1 times 1 is 1. Any number over 1 is a whole number, so in this case it would become 6. So let's look at a little bit of a recap. I found a lightsaber, watch this. So when we're finding 2 1/4 divided by 3/8, I've got 2 1/4. I change it into an improper fraction by doing 4 times 2 is 8. 8 plus 1 is 9 over the same denominator of 4. Keep my division sign, keep my second fraction. Then I move on to these steps here and I go to leave it, change it, flip it. Once I do all of that, once I do all of that, I can go across and do my cross factoring, and then it ends up being 6 over 1, which is 6. Example 2 is dividing mixed numbers. The first thing I'm going to do is I'm going to estimate this because now that I've got these whole numbers, it's easier to think about this way. So if I've got 3 and 5/6, let me get my pointer out here. Do a different one. If I got 3 and 5/6, 5/6 is really close to being 1. So 5/6 is really close to being a whole, being 1. I would look at that and say, well, that's kind of like having 4. Now I'm looking over here at my other one. I've got 1 and 2/3. Well, 2/3 is close to being a whole, so I can almost say that that would be 2. So 4 divided by 2 is 2. So we're going to kind of keep this over here and kind of come back to it. That's our estimate. The next thing I'm going to do is I'm going to take my first fraction, 3 and 5/6, and I'm going to make it into an improper fraction. So if I just go down like this, 6 times 3 is 18, plus 5 more is 23. So 6 times 3 is 18, plus 5 is 23, and I leave it over 6. Keep my division sign. 3 times 1 is 3, plus 2 more. There's my plus sign. Plus 2 more. I'm actually going to get rid of that. So 3 plus 2 more is 5. So then I have 5 over 3 because I keep the same denominator. And now I'm just left with a normal division problem. So I do my leave it, 23 over 6, change it. So I change my division sign to a multiplication sign, and then I flip it over 3/5. And again, I do my cross factoring. 3 can go into 6 very evenly. 6 divided by 3 is 2. So now I have 23 times 1 is 23, and 2 times 5 is 10. Now I take my improper fraction of 23 tenths, and I ask myself, how many times can 10 go into 23? 10, 20, so I can go in there 2 full times. 23 minus 20 is 3 left over, and I use the same denominator of tenths. So I have 2 and 3 tenths. So now let's compare this up here to my number 2. 3 tenths, if I thought about it on a pie, in like a pie chart here, if I were to separate this into tenths, it would look something like this. I kind of erased it and started over. But if I were to color in 3 of them, 1, 2, 3, it's not quite the whole thing, and it's a lot less than half of the whole thing. So what that's telling me is that it's close to being less than 1. So I just leave it at 2. That means my 2 is pretty close to that 2 if I were estimating. So it's a good check to do it that way. Example 3 is using order of operations. I'm going to ask you to evaluate 5 1/4 divided by 1 1/8 minus 2/3. Again, what we practiced the other day is we're going to use PEMDAS. And what I would like you to do in a situation like this is obviously rewrite it out. So I have 5 1/4 divided by 1 1/8 minus 2/3. I have been noticing a lot that you guys are copying these down wrong and you're getting the wrong answer because of it, which makes sense. And it's frustrating. So really make sure that you're copying down the correct numbers. So the first thing I'm going to start with is getting down to my number. And, sorry, I'm changing my color. I want to make them in proper fractions. So that's what I'm going to start with. So 5 times 4 is 20, plus 1 more is 21, and it's over 4. I'm leaving everything the same. 8 times 1 is 8, plus 1 is 9. Got 9 over 8, minus, and I don't have to do anything to 2/3. So now my PEMDAS tells me that I need to do division before I do anything else because I've only got a division and subtraction in there. So I've got division and subtraction. So this one comes first, this one comes second. But the problem is you can't forget to do that second part. So what I need to do next is I've got to just focus on this. Well, I'm going to go about the way that I've been practicing. I'm going to leave it, 21 over 4. I'm going to change it, and then I'm going to flip it. Now I can solve this. I'm going to look across and see if there's anywhere I can do a factor. I can factor. A lot of kids miss the fact that I can factor out 9 and 21 because I can get 3 to go into both of them. 9 divided by 3 is 3. 21 divided by 3 is 7. Just because they don't go into each other doesn't mean you can't factor them out. So be really careful about that. 4 can go into 4 one time, and it can also go into 8 2 times. So now I'm going straight across. I've got 7 times 2 is 14. And I've got 1 times 3 is 3. Now I have to remember that I have to bring down my minus 2/3. This one happened to work out really well because I've got thirds as my denominator. One thing I want you to write down in your notebook right now are these few rules. So copy this down over to the side or somewhere on your page, kind of like just a study tip. So I've got adding and subtraction with fractions. You have to have a common denominator. When you multiply and divide fractions, there's no need for one. So that I think you need to really understand and remember as you're doing fractions. So back to where I was, I've got 14/3 minus 2/3. I don't do anything on the bottom. I only subtract the top. 14 minus 2 is 12. And I leave it over 3. Okay? Now I have to ask myself, how many times does 3 go into 12? And it goes in 4 whole times. And our last example is the real life application that I spelled incorrectly. Oh dear. That's better. Okay, real life application. You do not have to write down the word problem that I do right now, but write down the work that I do below it, please. Okay. So 1 serving of tortilla soup is 1 2/3 cups. A restaurant cook makes 50 cups of soup. Is there enough to serve 35 people? Explain. So what we have to figure out here is that if we take 50 and we divide 50 by 1 2/3 to find the number of available servings, then we're going to figure out if we have enough to serve 35 people. And just like we talked about with the piece of wood, you have to think like I've got, and you don't have to draw this yet, but 50, these are my cups, okay. 50 cups of soup. Well, I don't have 50 cups of soup, obviously, that I'm going to draw out, but that's what they're saying. And if I have these 50 cups of soup, I wanted to actually divide them by 1 2/3 cup to see if that would make sense. That is why we put 50 first. So it's 50 divided by 1 2/3. Now we've learned that if you have 50 or any whole number, it just goes over itself. Or I'm sorry, it goes over 1, not itself. And then we can do 3 times 1 plus 2, which gives me 3, 4, 5 over 3, because I keep the same denominator. Now I set it up like this. I leave it. I change it. I flip it. Now I can see that I can do some cross factoring with my 5, because 5 can evenly go into 50. So I've got 5 divided by 5 is 1, 50 divided by 5 is 10. So 10 times 3 is 30. 1 times 1 is 1, which ends up equaling 30. So let's go back up to our question. Is there enough to serve 35 people? If I have 30 possible servings of this tortilla soup, then that means that no, I could not serve 35. So is there enough to serve 35 people? No. Because there's only enough to serve 30 total. And that's what I can conclude with my explanation. I'm only going to give you 2 try-its on this one, so go ahead and answer them, and then the answers will be worked out on the next page. Here's the first one. So I have 8 1/8. Follow my steps, see if you made any mistakes or if you got it, and then move on to the second one. And here's the answer for number 2. So you should have gotten 2. Follow through, see if you made any errors, and make sure you copied everything down correctly. And that's it.